Hello and welcome to the session. In this session, we will discuss about method of approximating definite integrals using numerical integration. We can approximate definite integrals using methods of numerical integration. We will discuss two methods of approximating definite integrals. That are trapezoidal rule and Simpson's rule. Let us start with trapezoidal rule. We can estimate area under curve y is equal to f of x in closed interval a to b using definite integrals. That is, the integral from a to b of f of x dx represents area under curve in closed interval a to b. In trapezoidal rule, we can approximate this area by using trapezoids. We partition the closed interval from a to b into n subintervals such that width of each subinterval is h equal to b minus a by n, such that there will be n plus 1 points x0, x1, x2 and so on till xn, such that a is equal to x0, less than x1, less than x2 and so on less than xn equal to b. Then form a trapezoid on each subinterval we know that area of trapezoid is equal to sum of two bases upon 2 into height. Because we have taken h is equal to b minus a by n, so the area of any trapezoid, say the ith trapezoid, is equal to f of xi minus 1 plus f of xi upon 2 into b minus a upon n. Because we have h is equal to b minus a upon n, this is equal to f of xi minus 1 plus f of xi upon 2 into h. Thus the sum of area of all trapezoids is equal to h into f of x0 plus f of x1 upon 2 plus f of x1 plus f of x2 upon 2 plus so on plus f of xn minus 1 plus f of xn whole upon 2. Therefore, this is equal to h by 2 into f of x0 plus 2f of x1 plus 2f of x2 plus 2f of x3 plus so on plus f of xn. Now if we take limit n tending to infinity, we will get integral from a to b of f of x dx is approximately equal to h by 2 into f of x0 plus twice f of x1 plus twice f of x2 plus twice f of x3 plus so on plus twice f of xn minus 1 plus f of xn, where h is equal to b minus a by n and x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h, x3 is equal to a plus 3h, and so on. Xn is equal to a plus nh, which is equal to b. Let us see an example. Using n equal to 4, find integral from 0 to pi sin x dx using trapezoidal rule. Now here a is equal to 0, b is equal to pi and n is given as 4. That means we will have 4 subintervals. So there will be n plus 1, that is 4 plus 1, which is equal to 5 points. That are x0, x1, x2, x3, x4. So we have a equal to x0 less than x1 less than x2 less than x3 less than x4 equal to b. x0 is equal to a, which is equal to 0. Width of each subinterval will be equal to h, which is equal to b minus a by n, that is pi minus 0 by 4, which is equal to pi by 4. So x1 is equal to a plus h, which is equal to 0 plus pi by 4, which is equal to pi by 4. x2 is equal to a plus 2h, which is equal to 0 plus 2 into pi by 4, which is equal to pi by 2. x3 is equal to a plus 3h, which is equal to 0 plus 3 into pi by 4, which is equal to 3 pi by 4. x4 is equal to b, which is equal to pi. We know that trapezoidal rule says that integral from a to b of f of x dx is approximately equal to h by 2 into f of x naught plus twice f of x1 plus twice f of x2 plus twice f of x3 plus so on plus twice f of xn minus 1 plus f of xn. So 0 to pi integral of sin x dx is approximately equal to pi by 4 upon 2 into f of x naught plus twice f of x1 plus twice f of x2 plus twice f of x3 plus f of x4. Thus, this is equal to pi by 8 into sine 0 plus 2 sine pi by 4 plus 2 sine pi by 2 plus 2 sine 3 pi by 4 plus sine pi. That is equal to pi by 8 into 0 plus 2 into 1 by root 2 plus 2 into 1 plus 2 into 1 by root 2 plus 0. That is approximately equal to pi by 8 into root 2 plus 2 plus root 2. That is approximately equal to pi by 8 into 2 root 2 plus 2, which is approximately equal to pi into root 2 plus 1 by 4, which is equal to 1.896. Now let us discuss Simpson's rule. In Simpson's rule, we divide the interval from a to b into n subintervals with the same width h is equal to b minus a by n, but here we take number of subintervals n to be even. Thus we define Simpson's rule as let fx be a continuous function on closed interval a to b and n is an even integer, then integral from a to b fx dx is approximately equal to h by 3 into f of x naught plus 4 f of x1 plus 2 into f of x2 plus 4 into f of x3 plus so on plus 4 into f of xn minus 1 plus f of xn, where h is equal to b minus a by n and x naught is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h, x3 is equal to a plus 3h, and so on. Xn is equal to a plus nh equal to b. Let us see the same example. We will now solve it using Simpson's rule. The example says that using n equal to 4, find the integral from 0 to pi sin x dx using Simpson's rule. So on applying Simpson's rule, we have 0 to pi integral of sin x dx is approximately equal to pi by 4 upon 3 into f of x naught plus 4 f of x1 plus 2 into f of x2 plus 4 into f of x3 plus f of x4. That is equal to pi by 12 into sine 0 plus 4 into sine pi by 4 plus 2 into sine pi by 2 plus 4 into sine 3 pi by 4 plus sine pi, which is equal to pi by 12 into 0 plus 4 into 1 by root 2 plus 2 into 1 plus 4 into 1 by root 2 plus 0, which is equal to pi by 12 into 2 root 2 plus 2 plus 2 root 2, which is equal to pi by 12 into 4 root 2 plus 2, that is equal to pi into 2 root 2 plus 1 the whole upon 6, that is approximately equal to 2.005. We may notice here that coefficients in the trapezoidal rule follow the pattern 1, 2, 2, 2 and so on till 2, 1, and coefficients in the Simpson's rule follow the pattern 1, 4, 2, 4, 2, 4 and so on till 4, 2, 4, 1. So in this session we have discussed about methods of approximating definite integrals using numerical integration. This completes our session. Hope you enjoyed the session.